I share my screen with you. Okay, I share my screen with you, and you can see my screen, and yes, now everybody can see my screen, and I start my presentation. Femex.ir is my Persian website, and it is for our Persian clients. And our YouTube channel is for all of our clients, even international or Persian. And My name is Amir Hossein. My family name is Mirza Bozorg, and I have Master of Science in Mechanical Engineering. And the topic of this webinar is how to resolve too many atoms error and introduction to other errors. As you know, too many atoms error is one of the common errors in Abaqus, and maybe all of you have experience about it. And after I uploaded the video of webinar in our YouTube channel, even after the webinar, you can ask your questions by writing comments below the webinar video in my YouTube channel, and I will answer it in reply to your comment. Also today, you can ask questions after my explanations are finished. Okay, after my explanations are finished, you can ask your questions, and I will answer all of them. Even the time of webinar exceeds 1 hour. Okay, I don't have any problem, and I don't have any program or plan after this webinar. So if it exceeds 1 hour, I will answer your questions which are related to this error. Okay, which are related to this error and convergence issues and all of the solutions which I tell you today. Also, we have a step-by-step guidance, tutoring, and consultancy services. I mean, online tutoring service and online consultancy service. And in the future, if you want, you can use these services also. This is the first part of the table of content of this webinar, and this is the second part, and this is the third part. Nicholas, is it only me which has not the presentation in full screen? Yeah, it is not. Actually, it is the when I use Google Meet. I think yes, it is not complete for you. Maybe uh, uh, because but check that maybe you can make it larger for yourself. I don't know, but there is no problem from my side. Okay, because I have set it to I have shared it in the all screen version. And this is the third part of the table of content, and this is the last part. I have put all of my experience about resolving this error in this webinar. First of all, I want to talk about the discount code from the 5th to 20th of October. We have this discount code, but you can use it earlier, okay, from tomorrow, which is 4th. And also, I will tell you your gift at the end of this webinar. And at the end of the webinar, I will talk about this discount code more, and it's for using, it's for buying the premium tutorials or extended premium packages of my YouTube channel. As you know, some of our videos are free in my YouTube channel. If I show you, this is my YouTube channel, and as you can see, some of the videos are free, okay. The videos which have free ticket, they are free, and some of them are premium, and also some of the free videos have premium, have extended premium package, and this discount can be used to buy all of the videos, and during the webinar I will talk about it more. Okay. Some of the Abaqus errors are common among all the Abaqus solvers, including errors related to the material definition or mesh quality. Suppose that you have several elements in your model that their quality is very bad. Then an error occurs relating to the bad quality of some of your elements in your model. For example, some of them, if they have negative volume or zero volume, you will face error when you are using tetrahedral elements. And such error is common between all the Abaqus solvers. Also, each of the Abaqus solvers has its errors. Too many attempts made for this increment is one of the common errors of the Abaqus standard solver. This error happens when the solver cannot find a converged solution for an increment. In this webinar, several solutions will be explained in detail to resolve this error. Yes, it is recording. Let me tell you that when we have convergence issues in the model, then several different errors can occur. One of them is the too many attempt error. The other one is the minimum time increment required is less than the minimum specified, and also some other errors. What I'm telling you today can be used for all of them, because all of them are due to convergence issues. And what I'm telling you is for resolving convergence issue, not especially too many attempt error, okay? Too many attempt error is one of the results of the convergence issues. So if we resolve the convergence issue, so we can resolve the error, okay? And so what I'm telling you is very general, okay? It's very general, and it is not limited to this error. When an Abaqus error occurs, first of all, before starting the analysis input file processor. Second, before the completion of the analysis input file processor. Third, before starting the solver. Usually it happens during the Abaqus explicit packager option operation. Let me tell you that Abaqus explicit has a packager, and its task is to divide the problem into several regions for parallelization. And each core of your system will solve one of the regions. For example, your system has 8 cores, and you have set it to for 6 cores. 6 cores of 8 cores be used in the analysis. And the Abaqus packager divides the problem into 6 regions. and each of the 6 cores will solve one of the regions. And the parallelization of Abaqus explicit is much better than Abaqus standard solver. And because Abaqus standard doesn't have packager, and sometimes during the packager operation, error happens. And finally, after starting the solver, when the simulation begins, here is a job monitor. Okay. Here is a job monitor of a simulation, and in this dialog box, the solver is Abaqus standard. If you see, started Abaqus standard. And in each of these stages, okay, in each of these stages, error can happen. I'm talking about error generally, not too many attempts, okay? Too many attempt error happens in this stage, okay? It happens in this stage. Also, in this job monitor box, the solver is Abaqus explicit. And as you can see here, we have the packager operation, okay? Too many attempt error does not happen when you are using Abaqus explicit, okay? Because Abaqus explicit doesn't have convergence issues. And because it uses explicit integration scheme, okay? There is no convergence criteria in Abaqus explicit. And for example, before starting the analysis input file processor, when we have error before starting the analysis input file processor, I want to show you one of these errors. For example, this error, which is related to the interaction module. When you have a mistake in defining an interaction, okay? And then you go to the interaction module to check it, and you will face this message, okay? It says that, for example, at least part of the region beam up, which is associated with the region to which the selected interaction is applied, has been suppressed, deleted, renamed, or excluded, or is part of a reference representation. One of the following actions must be taken. Resume the region if it was suppressed, redefine the named region, use the region editing function in the editor dialog to apply the interaction to a different region, or delete the interaction. And I want to show you this error in an Abaqus model. Here we have the model of 4-point bending test. And this is the assembly. The assembly consists of the beam and 4 rigid rollers. And here you can see the result. It is deformed. And I create a copy from this model, and I want to work on this model. In the interaction module, as you can see, we have 4 interactions, okay? 4 contact interactions between the beam and each of the rollers. For example, this one. I have defined master surface and a slave surface. And I change this definition. I go to Tools, Surface Manager, Create. I create a surface named Beam Up. Okay, Beam Up. And I select these 2 faces for the surface. And I use it in the contact definition. I change the slave surface definition. I set it to surface. I deactivate this setting. I go to surfaces and I select beam up. So the slave surface will be beam up. Now everything is correct. Suppose that you do a mistake. For example, the mistake is that we delete this surface. Okay, we delete it. Or you go to the mesh module and do partitioning. And the definition of this surface is changed because these faces are changed. Okay, this is another mistake. Because you must do all of the partitionings before going to the interaction and load module. You must not in the complex models, you must not follow according to this arrangement. Yes, you must not follow according to this arrangement. Okay, you must not follow according to this arrangement. I myself, I go to part, then property, then assembly, then I go to the mesh and do all of the meshings and partitionings, and then go to a step, then interaction, then load, and finally job. That's it. Yes, and I do like this. I go to the job module and create a job. I name it job test from this model. And I submit it. Now you can see the error. Okay, this is the error. This is before the start of the input file processor. Okay, this is before it. And how can I solve it? I go back to the interaction module and I edit interaction 1. And you can see that here we have problem, and easily if I reselect these surfaces, then it is resolved. That's it. This is one of the errors. Okay, it was only an example. For example, the next one, the error happens after starting the solver when the simulation begins. I have divided it into 3 kinds. First, in the early increments. It is usually due to the unsuccessful contact establishment in cases like bolted connections. And I will talk about this case later. Okay, later on I will talk about it completely. The next one, in the middle of the simulation or at the end of the simulation, which is the last increments. In such cases, it is due to large deformations, severe element distortions, and unsuccessful attempts to solve contact states. And I will talk about all of these later on. And as you know, we have 2 structural solvers in Abaqus. Abaqus standard, which uses implicit methods, and Abaqus explicit, which uses explicit methods. And each of these solvers has their own steps. For example, about Abaqus standard, we have a static general, dynamic implicit, coupled temp displacement, and a static Rix. And for the Abaqus explicit solver, for example, we have dynamic explicit step and dynamic temp disp explicit step. And these are several common and useful steps of these solvers. The too many attempt error happens when you are using these steps or some other steps of Abaqus standard solver. The error does not occur when you are using these steps because I told you in Abaqus explicit we don't have any convergence criteria or convergence issue. because it uses explicit integration scheme without any iteration. And here I want to talk about sources of nonlinearity in the analysis. Generally, we have three sources of nonlinearity. Nonlinear material like hyperelasticity, plasticity, or damage, and nonlinear boundary conditions like contact, and nonlinear geometry or large deformations. Here we have the full range nominal stress versus nominal strain curve. It is a typical mechanical behavior of ductile metals like steel. And as you can see, it has a linear elastic region, plastic region, and damage region. In this region, the material behavior is linear. But in this region, it is nonlinear, and in this region, it is highly nonlinear. Okay, it becomes highly nonlinear because we have softening, and Abaqus standard solver has a lot of issues in solving the damage. Okay, solving the damage. And also here, we have the full range nominal stress versus nominal strain curve of hyperelastic and rubber-like materials. In all of this curve, you can see that the behavior is completely nonlinear. The other source of nonlinearity is nonlinear boundary condition. Nonlinear boundary condition is a type of boundary condition that varies with time. Suppose this cantilever beam, we apply force at the center of it and it deforms. At the start of the analysis, there is no contact between the tip and the barrier. But when we increase the load, finally they have contact. And contact is a discontinuous phenomenon that makes the analysis nonlinear. Also, Abaqus standard solver has a lot of issues in solving complex contact states. And for solving them, it's better to use explicit solver. And I will talk about this later on. The final source of nonlinearity is nonlinear geometry. And suppose this cantilever beam again, we apply force at the tip of it and it deforms. And suppose that the force direction remains vertical. And when the deformation increases, this angle, will increase. And then you can divide the applied force into two components, normal component and tangential component. And when the angle increases, the tangential component will increases, so you cannot make simplifying assumptions again. Okay, it is the effect of nonlinear geometry. For the nonlinear geometry, we can have large deformations and rotations or pre-stress. Also, pre-stress is a kind of nonlinear geometry. Now I want to talk about linear and nonlinear analysis. In the static analysis, as you know, we have this general equation. This is the global stiffness matrix, and this is the displacement vector, and this is the external force vector. When there is no source of nonlinearity in the model, the analysis is fully linear. In this case, the K matrix and F vector do not change during the analysis. So the displacement vector can be found easily by multiplying the inverse of the K matrix with the F vector. We multiply the equation from left by inverse of K matrix, so U is equal to inverse of K multiplied by F. It is what you do during the finite element course in the university. And because in the finite element course, most of the time you work with the linear problems, and in the whole course you learn how to create a stiffness matrix for different kinds of elements and then solve this equation easily. Okay, but this is correct only for linear problems, not for nonlinear problems. When there are one or more sources of nonlinearity in the model, the K matrix or F vector varies with time. Hence, the solution cannot be found simply, and a nonlinear solver must be used. And in the next slides, I'm going to talk about nonlinear analysis and how Abaqus solves this equation when the K matrix or F matrix or both of them change. The main idea of solving nonlinear problem is dividing problem into several increments and solving them respectively. Here you can see the force displacement curve, and for example, in the ith increment, we want to solve this part of the curve. And here we have the amount, the added amount of load in the ith increment. This is delta P, and also delta U will be solved. And this portion of the problem has been solved previously. It is from the first increment to the I-1th increment. And ith increment will be solved using the Newton-Raphson method for solving nonlinear problems. And when the convergence conditions are satisfied, then we go to the next increment. Here you can see the time axis. It starts from 0 to t equal to total time. What is total time? Here, for example, this is the total time. 1 second. Okay, 1 second. In the static general step, this time period can be real or artificial. And also in the dynamic implicit step, it can be real or artificial. And here we are in the ith increment. Okay, delta P is equal to delta T divided by total time multiplied by P total. This is the total value of force or displacement. Okay, and this equation is correct for both the force control and displacement control loadings. About delta T, here I go to the incrementation tab, and in the slide the step is static general, and here it is dynamic implicit, but you can see that most of the settings are similar because both of them use the same solver. And in the Abaqus documentation, it is always suggested to set the type to automatic. Okay, to set the incrementation to automatic. When you set it to automatic, then the solver determines the value of delta T according to your settings. In the first increment, the time increment size is equal to delta T initial. And in the second to the last increment, delta T is between delta T minimum and delta T maximum. You must set these values according to your experience, okay? According to the experience and the level of the nonlinearity of the problem, you must define them. For example, when the loading is monotonic and you are doing a damage analysis using the dynamic implicit step or a static general step, the maximum value of time increment size must be set to 0.01 if the time period is 1. Okay, 0.1 is very large for damage analysis using the Abaqus standard solver. Okay, it's very large, but these settings are for a nonlinear problem with moderate nonlinearity. Okay, with moderate nonlinearity, not high nonlinearity. Okay. And here I want to talk about the attempts. For example, we are in the ith increment. When the solver starts to solve the ith increment, it determines the delta t according to your settings, okay, between the minimum and maximum. For example, it is 0.05. Delta t size is 0.05. It's between them for the ith increment. And the solver starts its first attempt. Determining delta t for first time between minimum and maximum is the first attempt. Okay, and during the first attempt, it conducts a lot of iterations to solve the nonlinear equations. If it is successful, then we go to the next attempt, we go to the next increment, to i+1 increment. But if it was not successful and the convergence criteria are not satisfied, then the solver conducts a cutback. This is the first cutback. And then it divides the value of delta t by 4. Okay? Let me show you. I suppose that the initial value of delta t is 0.05. Okay? Then, after cutback, the second attempt begins. In the second attempt, it is divided by 4. I divided by 4. So the value of delta t will be this value. Okay? And then it solves the nonlinear equations again. If it is successful, then solver goes to the next increment. But if it is not successful again, the solver conducts the second cutback and then divide it by 4 again. Okay, divide this one by 4 again. So I divide it by 4 again. This is the third value of delta t. Okay, and then the solver starts a third attempt. If it is successful, then solver goes to solve the next increment. But if it is not successful, then we have the third cutback, and then it is divided by 4 again. As you can see, the increment size is decreasing. Okay, it is decreasing. And it means that we have convergence issue in the ith increment. By default, the maximum allowable number of cutbacks is 4 and the maximum allowable number of attempts is 5. Okay? And after the fifth increment, the too many attempt error occurs. Too many attempts means that a lot of attempts have been conducted, but no convergence has happened. Okay, it means this, too many attempts made for this increment. It means that more attempts is needed. So the first solution to resolve this error is to increase the default values. Okay, we can increase the maximum number of attempts. We can increase them, and I will tell you how to do it. In this job monitor box, here you can see 5 continuous unsuccessful attempts, and U means unsuccessful. Okay, U means unsuccessful, but these increments were successful. Okay, these increments were successful, but the 11th increment, we have in the 11th increment we have convergence problem. And here you can see the severe discontinuity iteration column, and here you can see the equilibrium iteration column, and this is the total iteration column, which is equal to the sum of these two columns. Okay, sum of these two columns. And you can see that, for example, in the first attempt, after 3 iterations, okay, it is unsuccessful, and the solver goes to the second attempt and third attempt and fourth attempt and fifth attempt, and then we have too many attempt error. Okay, now I want to tell you how to increase the default values. Here, for example, I want to change the default value of attempts. I go to Other, General Solution Controls, Edit, Step 1. Here we have a warning. It says that you must be expert enough to change the solver settings appropriately. Okay, and I am expert enough, so I click on Continue, Specify, Time Incrementation, this one, and here we have IA. The default value is 5, which is the number of attempts. Okay, for highly nonlinear problems, you can set it to 10 or 15. Also, you can increase it. For example, you can set it to 100. But this is not a good solution, because if the problem cannot be converged in 15 attempts, it means that there is another issue. Okay, and you cannot resolve it only by increasing the number of cutbacks. You must resolve the other issue. Okay, and I will talk about all of these. Okay, so for example, for a damage analysis or a crack propagation analysis using the XFEM method, the best value can be 10 or 15. Okay, that's it. And the other solution is to increase I0 and IR. These parameters are related to the number of iterations. Okay, when you activate the discontinuous analysis option, these two values are increased to 8 and 10, from 4 to 8, from 8 to 10. Okay, and then Abaqus standard solver knows that it must do more iterations, because the problem is discontinuous, because it is highly nonlinear. Okay, and for doing that, I go to Other, General Solution Controls, Edit, Step 1, Specify. Here I activate this setting, so as you can see, the values are increased. And for now I want to talk about the other solution. It is about the contact analysis. And when you have contact interaction, you must use finer mesh in surfaces that are in contact with each other. For example, here you can see the simulation of the extrusion process, and here we have die, and here we have billet, and billet goes down and it is deformed. And as you can see in this region, which is not straight like these regions, okay, these regions are straight, but it is not straight, it has a curve, okay, it has curvature. In this region, I have used finer mesh, okay, to resolve the convergence issues, okay. And next, I want to talk about the guidelines for modeling the this is our first reference paper. It is about the guidelines for modeling the preloading bolts in the structure connection using finite element methods. In this paper, it is mentioned that previously the bolts as well as bolt hole region are quarter partitioned. Then they mesh with 16 elements around the circumference. For example, as you can see in here, I have done the meshing according to the paper. Okay, this is the example of chapter 9 of my comprehensive Abaqus package. And for example, here, as you can see, I have divided the hole into 4 regions, okay, both holes and also the bolt. Okay, I have divided them into 4 regions, and on each region 4 elements must be created. And for example, for meshing the plate, I have used sweep technique, okay, sweep technique and medial axis algorithm. Here I want to introduce you several chapters of my comprehensive Abaqus package. And for example, I want to talk about chapter 5, which is related to meshing and partitioning, and chapter 9, example 2, which is related to bolt connection analysis. And this is my YouTube channel, okay. If you have not subscribed, you can subscribe on it. If you search Femex, you can find it. And this is the overview. Here we have the overview of the comprehensive Abaqus package, and also each chapter has its own preview, and you can buy each chapter separately. Okay, you can buy each chapter separately, and also you can use the discount code which I told you at the start of the webinar to buy each of these chapters or each of the packages or sub packages of comprehensive Abaqus package. For example, here
piles of paperwork and no time for strategic HR.
Here actually all of our videos have a full description, okay, and you can read each of the descriptions, but let me tell you something about the prices. Actually, each of the chapters has its own price, and these values are the summation of the prices of all the included chapters. But the price of the packages are these values, okay? And if you use discount to buy them, okay, then the discount will be applied to this value, not this value, okay? That's it. You are welcome. Next, yes, I wanted to tell you this point, and I go back to the presentation, and here I have talked about the our packages and about the comprehensive Abaqus package and its chapters. Another thing. Yes, we have these packages also. This is the full package, and these are the sub packages. And also, you can buy each chapter separately. And about the packages and sub packages, you can buy them in 2, 3, or 4 installments according to your budget or income, and the maximum period between each 2 installment payments should not exceed 1 month. After each payment, you will have access to several chapters of the package. If you buy a package using a discount code, you cannot purchase it in more than 2 installments. Okay. And also we have these gifts for the buyers, and the first gift is a permanent 30% discount to purchase every premium package or tutorial on the Femex YouTube channel. This 30% cannot be summed with the discount codes, okay? It's separately, okay? And also a 30% discount on online tutoring and consultancy services. This discount is valid for up to 4 months. And in the reference paper, they have mentioned that numerical results are highly sensitive to the contact properties between components of the joints and the preloaded bolts. A small sliding surface-to-surface discretization method was considered for all the contacts. The surface contact properties between the plate elements were modeled as a tangential behavior using penalty friction with the friction coefficient value of 0.44. Normal behavior contact properties using augmented Lagrange formulation were considered for the normal forces. Now I'm gonna show you the these settings in the models of chapter 9 of my package. In the interaction property manager, I have defined interaction property, and I have set the friction coefficient equal to 0.44 like the paper. And for the normal behavior, they have suggested that for the constraint enforcement method, use the augmented Lagrange. Okay, if you use this option, the accuracy of the simulation increases, but it's a complex formulation, and you will face convergence issues again. So in another model, I have used the default settings. Okay, I have used the default settings. Here, as you can see, I have not defined any normal behavior. When you don't define the normal behavior, the default settings will be used. These settings. And the constraint enforcement method is set to default. Okay. This combination will be solved easier than when you set it to augmented Lagrange. And also in my model, I have used general contact, okay, instead of the surface-to-surface contact with a small sliding formulation. Actually, both of them can work, okay. General contact is good in some of the simulations, I mean for bolted connection analysis, and also a small sliding formulation can be used for some others. For example, first you can try general contact, and if it didn't work, you can switch to the small sliding formulation for surface-to-surface contact. For example, if I want to use a small sliding formulation, in this case, here I create a copy from it, okay? And as you can see, here we have a lot of contact interactions, okay? And if I want to define them one by one, it will be very time consuming. So here I use the find contact pair tool. Okay, I set the tolerance to a small value, for example this value, and I click on find contact pairs. And as you can see, these contact pairs are found. Okay, these contact pairs are found. And the sliding formulation is finite. Okay, now I change all of them to a small sliding, like what has been mentioned in the paper. Okay, and here you can see that we have both of them. Okay, the priority of the surface to surface contact is more than the general contact. Okay, and in this case, as we have defined surface to surface contact for all of the contacting surfaces, general contact will not be used at all. Okay, even if you define it, it will not be used at all. But if I deactivate them, or for example, if I deactivate this one, then general contact will be used between the surfaces which their interaction are defined according to this one. Okay, according to this one, and now it is deactivated, so general contact will be applied. And okay, I go ahead. For appropriate contact definition, I told you we have two options. First, using general contact instead of surface to surface contact with finite sliding formulation, or surface to surface contact with the small sliding formulation. This one is suggested in the papers, and I have used this one in chapter 9 of my comprehensive Abaqus package. And also this one works in some of the simulations. And the other solution is using automatic stabilization in the contact controls. Also, I have talked about contact theories in Abaqus in chapter 8 of my comprehensive Abaqus package. And here you can see the chapter 8. Chapter 8 is not free, but you cannot buy it separately. If you buy one of the parts of chapter 9, or second part of chapter 11, or chapter 14, or chapter 16, then I will give it to you for free, because in these tutorials I have defined contact interaction, so you must know about contact definition in Abaqus. Okay, the next reference paper is this one, numerical modeling of restrained structural sub-assemblies of a steel beam and CFD columns connected with reverse channels in fire. And in the paper, in the contact parameters definition, it is said that they have used surface to surface contact with a small sliding option, and they have used hard contact with the friction coefficient equal to 0.3, and they have mentioned that the friction coefficient values have been found to have little effect on the simulation results. Also, they have suggested a small sliding. And in the simulation of a deep drawing process in the 3D domain, or even in the axisymmetric domain or 2D domain, if you use Abaqus standard solver, for having a converged solution, you must define automatic stabilization in the contact controls. Here you can see the 1/4 of the deep drawing model, and I have used symmetry boundary conditions here. This is the punch, this is the holder, and this is the die, and here you can see the finite element model. And if you want to define automatic stabilization in the contact controls, you must go to the model tree, okay, in the contact controls, and define a contact control and set it to automatic stabilization and define the factor. For example, here I have set it to 0.001, and in the surface to surface contact definition, here you must add your contact controls, okay? If I do this here, for example, here we have contact controls. I double click on it, Abaqus standard contact controls, automatic stabilization, 0.001, and I edit the contact controls here. That's it. Now it is defined. But for the bolted connections, usually we don't use this option, okay? We usually don't use this option, and it is not needed. But I wanted to show you how to define it. Okay. Now I'm gonna talk about the next solution. It is changing the element type or formulation. Changing the element formulation from reduced integration to full integration or vice versa, as the reduced integration elements do not have bending stiffness in some cases, they undergo unreal deformations which can lead to convergence error. In such cases, the element size should be decreased or the element type must be changed to full integration. In this case, for example, for the plate, okay? For the plate, I go to assign element type, and as you can see, the element type is C3D8R, and it is set to reduce integration. If I deactivate this setting, the element will be full integration, or C3D8, okay? Or C3D8. And changing the element type from first order to the second order or vice versa when applicable. For example, here I go to the assign element type again and change the geometric order to quadratic, okay? Change it to quadratic, and for the quadratic elements, most of the time the quadratic reduced integration element is better, okay? It is an appropriate element. So I don't deactivate the reduced integration setting for the quadratic elements. But for the linear case, sometimes we should do it to resolve convergence issues due to the artificial deformations of the reduced integration elements. But for this case, there is no need to deactivate it. And the next solution is changing the step and solver. Basically, this is the most important solution for resolving the convergence issues, especially the too many atoms error. Changing the step from the static general to dynamic implicit, or changing the solver from Abaqus standard to Abaqus explicit. And in this case, it means changing a static general dynamic implicit or a static Rix steps to dynamic explicit step, or changing coupled temp displacement step to dynamic temp disp explicit step. Okay, so when we change solver, we must also change the step, because each solver has its own steps. But we can change a step without changing the solver, like this, when both steps use the same solver. Okay, in this case, for example, we can replace the static general step with the dynamic explicit or dynamic implicit steps. And if you see, for example, in this analysis, in model 2, for the first two steps, I have used a static general, and in model 3, I have defined a dynamic explicit step instead of the third static general step, okay? Because the original analysis consists of 3 steps, okay? 3 static general steps. In model 2, I solve step 1 and step 2, and for step 3, I create another model and continue the simulation in another model. It is named import analysis technique or sequential analysis, okay? And if you want to do this setting, you must if you want to do this procedure, you must import the results of model 2 to model 3. So the final solution of model 2 will be the initial condition of model 3. Why we do this? Because you cannot use both the solvers in one analysis, okay? All the steps must belong to Abaqus explicit, or all the steps must belong to the Abaqus standard solver. For example, here, if I want to create a new step, you can see that you cannot select Abaqus explicit steps, okay? You cannot select them. That's it. Yes, you are here. Very good. Okay, if you want to use the dynamic implicit step instead of the static general step, you must set the application to quasi-static. Okay. Generally, dynamic implicit step is developed for solving nonlinear dynamic problems. But when you set the application to quasi-static, you can also solve quasi-static or static problems using this step. Since the dynamic implicit step considers the effect of inertial forces in the model, the chance of convergence in very nonlinear problems will increase, because the consideration of inertial forces terms in solving the equations helps the stability of the problem. And if you cannot solve the problem using the dynamic implicit step, you can change your solver and use Abaqus explicit instead of Abaqus standard and use the dynamic explicit step. Notice that the typical time increment size of the explicit solver is 10 to the power of -6 or less. Because the time period of a static or quasi-static analysis is usually equal or more than 1 second, more than 10 to the power of 6 increments are needed to solve the problem. And it will take a lot of time, even with parallel processing. To overcome this problem, the loading rate or mass scale techniques must be used. For example, in model 3, I have used the mass scaling, okay? I have used the mass scaling, and I have set the target time increment to 2 multiplied by 10 to the power of -6, okay? So the solver uses this time increment to solve the problem and do the simulation. And it is more than the original stable time increment size. The other solution is changing the maximum value of failure index. This solution can be used when you want to conduct damage analysis using the Abaqus standard solver, okay? But in other cases, if you have not defined damage in your model, so this solution cannot be used, okay? As the Abaqus standard solver uses implicit algorithms to solve nonlinear analysis, solving models including damage behavior leads to convergence issues when using this solver. I talked about this issue earlier, if you remember, when I told you that damage behavior makes the simulation highly nonlinear because Abaqus standard and also Abaqus standard solver has problem in solving softening. When the damage parameter has reached 0.98 or more in all the integration points of an element, a convergence issue arises and the time increment size decreases drastically until the damage parameter reaches 1 and the element is removed from the simulation. Hence, by setting the failure index to a value less than unity, the convergence issue will be resolved automatically and the time increment size will not decrease drastically anymore. To change the maximum value of failure index, okay, in the element type setting, you must go to the max degradation and set it to specify. For example, I have set it to 0.98. Also, you can set it to 0.98, 0.985 or 0.99 for getting more accurate results. And also, I have talked about damage in chapter 11 of my comprehensive Abaqus package. If you want to do quasi-static damage analysis, you can buy the first part of chapter 11, or if you want to do dynamic damage analysis like high velocity impact or low velocity impact, you can buy the second part of chapter 11, and here you can see them in my YouTube channel. And also we have another premium tutorial for damage analysis. It's here. And also it is related to ductile damage model. And it also includes verification with a paper. And the other solution is changing Rn alpha and Cn alpha. Okay. First, I want to show you this dialog box in Abaqus. I go to Other, General Solution Controls, Edit, Step 3. Oh, sorry. In Model 3, it uses explicit solver. So I go to Other, General Solution Controls, Edit, Step 1, for example. And here you can see these parameters. These are the parameters of nonlinear solver. Okay, these are the parameters related to nonlinear solution. And in this picture is from the Abaqus documentation. Okay, and here you can read the description of Rn alpha and Cn alpha. Okay, these are two parameters related to the convergence criteria for the nonlinear finite element analysis. And if we increase these values, okay, if we increase these values, the convergence can occur more easily. And this is the other solution to solve the convergence issues generally and too many atoms error especially. For example, if I multiply them by 20, Rn alpha will be 0.1 and Cn alpha will be 0.2. Okay? When you do this, actually the accuracy of the simulation will decrease. Okay? And but your the chance of convergence will increase in your nonlinear simulation. Here I have done this, and the final solution for resolving the error is using automatic stabilization when you are using a static general step. When you define automatic stabilization like this, if I show you, here I have defined automatic stabilization. By default, it is set to none. And here I define it, okay? Usually these default values are appropriate enough. But in some cases, you must decrease them or even deactivate this setting and use smaller values here. And in the second reference paper, they have done a good investigation on this value, okay? If I show you here, this is the reference paper, the second reference paper. And here, artificial damping energy dissipation factor. They have done a good investigation of the value of damping factor. When you define it, artificial damping forces will be introduced to the simulation, and they cause convergence, and they cause stability in the numerical solution. But they will affect the solution, and if this coefficient is increased, the accuracy will decrease, okay? But to resolve this issue generally, I suggest you to use dynamic implicit step instead of the static general step. Because when you use the dynamic implicit step and set its application to quasi-static, it will be much better than use the static general step. And even to remodel this paper, I use the dynamic implicit step instead of the static general step in one of my online tutoring sessions. Recently, I have worked on this paper with one of my students, and I used dynamic implicit step for his model, and it worked, okay? And we didn't define any damping factor, and because dynamic implicit step doesn't use it, okay? And now I want to talk about the 50% discount code again. This is the discount code slides. The discount code is October 2023, and the discount percentage is 50%. If you want to purchase any premium tutorials and packages with a discount, please send us the names of the tutorials or packages with the discount code. You can send an email or text us via Telegram or WhatsApp. You can use this phone number to text me in Telegram or WhatsApp, or you can send email to me to buy the premium tutorials or packages with the discount code, and you must send the discount code with the name of the tutorials which you want to buy. And as you know, we have two kinds of tutorials in our YouTube channel. They are free tutorials and premium tutorials. And some of the free tutorials have extended premium packages, and also we have the premium tutorials. The prices, excluding any discounts, are outlined in the description below the videos. as I showed you for the comprehensive Abaqus package. When you provide us with the discount code October 2023, you will only be required to pay half of the stated prices. If you specify the names of the premium tutorials or packages you desire without mentioning the discount code, the 50% discount will not be applied to your orders. The discount code can be utilized multiple times between October 5th and 20th. There are no restrictions on the quantity of premium tutorials or packages you can purchase using the discount. The sole limitation on the discount code is its expiration, which is the end of October 20th. And you can contact me by sending message in Telegram or WhatsApp via this number, or send email to me. And these are our premium services. And about the gift of participants. The participants of this webinar, you can use the discount code October 2023 even when it is expired for the others, okay? And you can use it one more time even when it is expired for the others. Even you can use it in the next year, but only for one time, okay? Only for one time after the 20th of October 2023 you can use it, and you can buy several tutorials using this discount when you text me, and yes, this is your gift that you can use it without limitation for one time after it is expired for the others. And thank you so much for your time. And now you can ask your questions. If you have any questions, please ask me. Yes, please ask. You can speak.
I have one. Do you hear me?
Yes.
Yes, I have one question to you. For me, I'm a beginner in Abaqus because I'm civil engineering, and right now I will pass to mechanical engineering, structural offshore. And if you have any advice to me for your course or for something like that to start with that, what are your suggestions to me? And
very good.
yes.
Okay.
If my second question, if you have any documentation of Abaqus that you can help me of that,
yes,
I will take that. So
yes. Your bachelor is civil and now your master is mechanic.
No, I was working like a civil engineering, and right now I will work like mechanical engineering. Your offshore part.
You say that your working position is now as a mechanical engineer, but your background is civil engineering.
Yeah.
Very good. I suggest you to buy the full package, okay? Because because your background is civil and now you must work as a mechanical, okay? So I suggest you to buy the full package, and as I told you, at present its cost is 165 euros, and if you use discount it will be 83 euros for you. And also you can pay it in 2 installments, and you can learn it. It is from beginning, and it is from beginning to advance, okay? And it is completely comprehensive. Yes, actually I have put all of my 10-year experience of working with Abaqus into this course, and as I told you, chapter 13 is for free, okay? Even at present you can watch chapter 13. It is completely uploaded, to be more familiar with my package. And also, even after finishing the package, you can take 3 exams. Here I have explained about it. You can take 3 exams, and we can give you certificate, okay, after you pass 3 exams, okay. After you pass 3 exams, Abaqus exams, online exams, I can give you certificate even for this. And yes, this is, I think, for you as a beginner, this is the best choice. Yes, and also if you check my YouTube channel, I have a lot of free videos, okay. I have a lot of free videos, and even, for example, if you see, all of these are free. For example, the simulation of 4-point bending test, it is a complete tutorial, okay. It is a complete tutorial of simulating 4-point bending test, and a lot of tutorials about meshing. You can check our playlists, okay. You can check our playlists. We have a lot of free videos, and even for the too many attempt error, we have a video. But this is the old version of my knowledge, okay. This is the old version of my knowledge, and now I presented the new version of my knowledge about resolving this error. And yes, it is the previous one. That's it. And if you have any other questions, you can ask. Sina, do you have any questions? You can ask me.
No, everything was clear. Thank you.
You are welcome. As usual, very good that this time everything was clear. Okay, Mohammed, do you have any other questions?
Yeah.
Yes, please ask.
My second question, it's about a documentation. In the video, we have a video, but we don't have any documentation. So if I buy your course, I will have this I will have some documentation with that, or just videos.
No, slides. Yes, you have. See here. I now I understand your question. If you let me show you. Also, everybody who buys one of the full package or its sub packages, you will have these gifts. And also here I have mentioned that each chapter includes CAE, JNL, and IMP files, step-by-step tutorials with detailed explanations and investigation of the results, and also slides and reference papers and standards, okay. Because I always teach with slides, okay, like this webinar. And also I will provide you slides for each chapter, okay. Yes, so you will have a lot of documentation. And even I teach you how to use Abaqus documentation, okay, which is the most complete reference for Abaqus in chapter 12, okay. In chapter 12, here it is, chapter 12, using Abaqus documentation, okay. Here, for example, I search for Abaqus documentation, okay. You have free access to some of the Abaqus documentations, and even if you create an account in the 3DS website, you have access to the to all of the Abaqus documentations for all of the versions. But here you can see that without going to the 3DS website, you can have access to 6.14 version documentation, and I have taught how to use this documentation, okay. And so by learning how to use this documentation, you will be independent. Okay, you will be totally independent, and this is the last stage that you can reach. Okay, and by studying my package, you finally reach this stage. Okay, you finally reach this stage because I have taught how to use this documentation. It is the most complete reference for Abaqus. Okay, and it is written in English, and you know English. Okay, you know English, but at present you cannot use it because you don't know how to find the answer of your questions in each of these sections. Okay,
Yeah.
and what is in each section, what is in this section. Okay, and for example, you want to know about damage analysis. Okay, or please tell me a topic, please tell me a topic. What is your, at present, for example, one of your concerns in learning Abaqus? Can you tell me?
Yeah, I was in offshore park parts of civil engineering, and right now I will be in subsea. So we have connected many pipeline for our plate. I don't know if you.
Subsea. Okay. For
Yeah,
subsea, for example, what is important for subsea? Let me tell you that in the future, I will hold a course related to DNV standard. Do you know DNV standard for offshore engineering? DNV. Do you know?
DNV, yes, DNV, yes.
DNV, yes, very good. This is the in the future, I will give a course according to the DNV standard. Okay, but it is for the future. This standard. Okay, but for example, in the documentation, if I want to show you something related to subsea, in the for example, buckling. Okay, buckling analysis. Here, for example, I go to the analysis techniques, modeling, no, analysis conditions, no, analysis techniques introduction. In this case, we don't have it. Static stress displacement analysis. Eigenvalue buckling prediction. Okay. For example, after watching chapter 12, you know how to read this section. Okay, you know how to read this section. Okay, and what does it mean? Okay. Yes, you will understand how to use it. Or for example, another thing, if I go to analysis techniques, no, I want to show you the collapse analysis. If I find it, the collapse analysis is very interesting in Abaqus. If I show you, it's not here. Collapse analysis. Yes, here, sorry. Unstable collapse and post-buckling analysis. It is very important in offshore engineering. And after, for example, in my Abaqus comprehensive package, in chapter 10, I have talked about Rick's method completely. Okay, Rick's method completely. And then you know how to read these explanations. Okay, what does it mean? That's it. Or for example, you want to know about the plasticity. Okay, you want to know about the plasticity. You go to the material in elastic mechanical properties, metal plasticity, classical metal plasticity, and then you you can read these explanations very easily. Okay, at present they are in English. Okay, and you know English, but if you read them you don't understand. Okay, because English language is not enough for understanding Abaqus documentation. If it was enough, then nobody holds Abaqus classes. Okay, there was no need.
Okay.
Yes, there was no need. But why people participate in the courses? For example, you have participated in this webinar because this documentation, because you must have enough knowledge for understanding the documentation. Yes, that's it. Do you have any other question?
I have my third question. It's my the final question.
Yes.
My question it's when I buy this course, you will send me a links or what? Or I will have.
I will share. I will share via Google Drive. I will share.
Drive.
Yes,
Okay.
each chapter via Google Drive, and you have unlimited access. Okay, you have unlimited access to the material of the course, and yes, unlimited access, and I share them via Google Drive with you.
Okay.
Yes.
The price it's 83.
At present, with the discount code, yes. But in the future, I will give updates for the course. Okay. And also, if you buy, for example, at present, if you buy the package, okay, the future updates will be free for you. But if somebody, but after giving the updates, I will increase the price for the new buyers. Okay, not you.
Okay.
Yes, that's it.
And my question is, we can download that in your PC or just in Drive? It's keeping in Drive or?
No. You when you have access to the folders, then you can download from the folders. Okay. Yes. Okay. Not in my system. No. I shared. It is not shared in my system. I share my drive with your drive. Then you have them in your drive. Then you can download them and have them in your PC. Yes. Okay, there is no limitation. And Sina, do you have any other questions?
No.
Very good. Okay. I think you want to sleep. No, it's not the time of sleep. It's 9 p.m. in Central Europe. 9 near time 9 p.m. Thank you so much for your participation, and it was a very good webinar. And sorry again for the interruption. And have a good time and goodbye.
Thank you.
You are welcome. Goodbye.
Bye.